Hi, I'm Kelsey. I'm an OpenSciEd teacher and facilitator. This video is for Lesson 8 in Unit 6.2. This is a great investigation in this lesson, but there are a lot of moving parts, so I have some tips and tricks to help you along. So let's get started. How we got here. In the previous lesson, students generated ideas for what could cause liquids in cold systems to change temperature. And we also brainstormed some ideas to investigate those ideas as well. We figured out that since most of the matter does not enter or leave the cup system with the lid, light and heat or cold may interact with the system to cause a temperature change to the liquid inside. In this lesson, we are wondering, how does a cup's surface affect how light warms up a liquid inside the cup? Here's the lesson at a glance. This is an investigation lesson. It's 2 days long, 60 minutes of material prep time. There is a hands-on investigation, but no device is needed and no videos used. So in this lesson, we have one sense-making loop. We carry out an investigation into how the surface of the cup interacts with light and affects the temperature of the cold water inside the cup. We analyze the data from that investigation. Then we make sense of the data together, modeling what we figured out. From this, we figure out that light energy is transferred into the system and warms up the liquid inside, but cups that are not exposed to light also warm up. So in this lesson, we figure out that light can transfer energy into a system. When light that shines on a surface is not reflected or transmitted, it is absorbed, which warms the matter that it shines on. Temperature changes in the water can still occur even if light does not transmit through the cup wall and even if there's no light. We're left wondering, how do liquids warm up when there is no light? I have two key moments I'm going to go into a little more detail here. The first is part 4 when we analyze data from the light and temperature investigation. This investigation requires many different groups testing cups in different conditions and then pooling the temperature data along with light measurements for reflected and transmitted light. I have two samples from classes on the screen. At this point in the lesson, it's important to help students make sense and see the general patterns after putting all this data together. The general patterns you want students to see here is that light is interacting with the cups differently, causing different temperature changes. Some cups reflect and transmit different amounts of light, and we conclude that the light that is not reflected and transmitted is absorbed, leading to temperature changes. And the cups that were in the dark still warm up. Those are the general patterns you're looking for here. In part 5, we are developing models to explain these temperature changes. So we're still in the circle here, and you develop these models you see on the screen together to explain how the light interacts with the different surfaces of cups. We also co-develop a way to show absorption, which you can see right here with the black cup. So students continue to sense make here using modeling conventions previously developed in 6.1 and adding a new way to show light absorption. So I have several material management tips and tricks that I'm going to quickly go through. The first is to define energy. So the framework, science framework, according to the framework, students learn or figure out what energy is and how it's different from matter in elementary school. So if you know that your students haven't gotten that yet, I would add that in here, and I would actually add it in before this lesson. So it might sound something like this. At the end of lesson 7, when students are talking about how light is going to warm up a cup or a liquid, and they talk about how the temperature around is going to warm it up, I would say something like, so you're talking about these things and they're actually energy. Have you ever heard that word? Have you heard that? Do you know what it is? And a lot of students say, yes, I've heard of energy. And then you can say, so what is energy? Like, what is it? If we were going to put it on the word wall, what would we write? And you might get some very different ideas, or you might get some blank stares, and you say, okay, so let's define energy. Let's figure out what it is, define it, and then we can start investigating it. So That's where I add in, for us, we just add in a really simple article that we've developed. There are ideas on the Facebook groups for a little more hands-on activities, but I need a definition of energy. I need my students to understand the difference between matter and energy before we move forward with this lesson set. So you can see on the screen, there's two definitions that classes of mine developed. These are not they're not textbook definitions, but they're working definitions that we can at least use. And I just need my students to understand a couple key things about energy. One is that it doesn't have mass, it doesn't take up space, it's not made of particles. You might see on some of their models them actually drawing particles of energy. So that's a good indication that you want to go into a little bit more of the energy aspect here. Um, Not made of particles. You want them to understand that it can be transferred and that it comes in a couple different forms. So as long as you're getting that at this point, you can use that definition going forward. And I do add it onto the word wall here. Okay, some things about materials prep. So there's a lot of things to prep for this investigation. I encourage you to read the materials preparation section of the teacher's edition. You're going to need cups painted white and black. You're going to need cups covered in foil. You're going to need some templates printed out. I put them in sheet protectors so I can reuse them. The good thing is that once you make this stuff, you can reuse it in the coming years. I made all of these cups the first time, and then I've mostly been able to just reuse them every year, which cuts down on the prep. But if you haven't set this up and you're trying to teach this tomorrow, you might need to check that materials prep. Last thing I'll say about this is that you do need data tables for all of your classes. You can do this on a big poster paper like is shown at the bottom of the screen. I do it digitally because it saves me time. It's not something that needs to go up on the wall later. So digital works great for me. A note about the use of math in this lesson. Students are asked to average their data with other groups who tested the same thing. They also are asked to calculate percentages in this lesson. So my tip is you can check with your math teachers and see if how much experience students have with these skills, but don't get bogged down in this math too much. Balance building these skills with time management. As long as students understand what the calculations mean, you don't need to spend a huge amount of time building the math skills or making sure that most of your students can do this independently. That's their math teacher's job. As long as they know what the numbers mean, you can move on. I know that I have wasted a few class periods trying to do this, and it's not necessary at this point. Okay, the last tip here is for part 5, where we're developing models to explain the temperature change. So when students are gathering data in this investigation, there's a lot of room for error. You might end up with some variability. Your class's data might look different from the data that's in the teacher's edition. So when you're doing this modeling, just think about it more of a comparison. Try not to get bogged down in the data and making really precise models that match the data. Just keep in mind that there's really just two main goals here with this modeling, and those are that we want to explain with these models how different surface cups interact with light differently and cause water to warm up differently. And we want to develop a way to show light being absorbed. So just thinking about a comparison, like comparing the clear cup with the foil cup or comparing a white cup with the black cup, is helpful. These two ideas of surfaces affecting light interaction differently, that is built more out in unit 6.3 in the weather unit. So you could keep that in mind. And then last thing about this is that if you have not done the 6.1 unit, you might not have these modeling conventions developed with your students yet. So keep that in mind as well. Okay, word wall management. You won't be adding any words unless you add that energy to the word wall. Poster management, we're not really using any posters from previous lessons, and we don't add anything that needs to go up on the wall permanently. And that's it. So in this lesson, we figured out some really important stuff about light. In the next lesson, we're going to start to investigate how the temperature around a cup system can affect what's inside. And that will be in the next video.